Started here. Everybody say hi really quick and then be quiet.
Oh, you didn't even start. I saw you.
Yeah, it started.
No, you tried.
Okay. So, all of you on B should have your blue book in front of you, in front of your computer. Go ahead and open up the first note page and title it Motion Graphs like you can see here. But just like we talked about and hopefully experienced a little bit in the computer lab, motion and velocity and acceleration are graphable, right? And in physics, we need to make sure that those things are quantifiable, which that's where graphs come in. So I'm going to go full screen here. It's not going to take too long to do these notes, but just follow along with me. If you have any questions, let me know. So the first thing we need to get down here is kind of what these graphs look like, okay? So, let's go ahead and draw just a simple graph here. Okay, you'll see graphs that look like this. You'll see graphs that look like this. Alright, what's the difference here? This has a positive quadrant, this has a negative quadrant. This one is really only positive. Okay? The most important thing when looking at a motion graph is by understanding the axes. Right, and what each axis is. I'll tell you right now, you can memorize this. This axis, which is what? The one that goes left to right here. That is your x-axis, is always, always, always going to be time. Okay, so this is going to be t for time. Okay, so this axis is always time. So really, how is position changing over time? Okay. And then on this axis over here, okay, we're going to do a couple different things. We're going to start out with position, okay. So we can write that. Okay, position is given in either a unit of distance. Maybe it's abbreviated by D, sometimes it's abbreviated by X, like you'll see on this homework tonight. Okay. But position is just really the separation between an object and a reference point. Now, what does that mean? Well, if I describe my position, would it make sense to just say, I'm in the middle? No, what would be more accurate? Because I'm in the middle of this classroom. So what's the reference? The classroom. I could say though, I am on the east side of the campus, right? I could say I'm on the west side of the United States. So the reference point matters, okay? But usually we're just going to give position as a number, so like meters or feet or miles, okay? So let's go ahead and write down some possible units for position, because it's going to be really important for you guys to recognize when we're talking about distance, when we're going to talk about a velocity, blah, blah. So what is a unit of distance? We already said meters. Shout them out. What are some examples? Inches. Feet.
Kilometer.
Miles. Kilometers, if you're from Europe. Okay, you guys get the idea. Alright? So, position can be on, like we said, the y-axis. Okay? What's the other one we saw on the y-axis from our computer lab?
Wait, what?
Yep, I heard somebody say it. Velocity. Alright, AKA speed. There's a little bit of difference between the two, but I'm not going to quite get into that yet. Okay, speed is labeled with V or S for speed. Alright. So this is the rate at which an object's position changes, right? The rate at which an object's position changes. Najib, question?
I was going to ask you, for accuracy, like, I don't know, like, what difference did it make on the man, like, the guy we were doing in the library?
Say that again?
Like, the thing we were doing on the computer, for the accuracy, like, what was his job? Because I didn't really see it.
For accuracy? Oh, acceleration?
No, but, like, no, not close. It's like, you told me, like, well, you were helping me on B, and then you were like, the accuracy.
Oh, I was asking you to check your accuracy. So you would actually, you were predicting what would happen, then you were checking to see if it was accurate. But again, I'm not too worried about accuracy quite yet. Okay? The rate at which an object's position changes, so velocity. So it's speed, right? What kind of units do we use for speed? MPH is miles per hour. The one we're going to use in here mostly is meters per second. I'm going to circle that one. And then we're also going to use meters as a standard unit for position. You can circle that one.
We're going to use km as well.
km?
Yeah, kilometers. Or
kilometers
per hour.
Not so much. Oh, so for this one down here, yeah, kilometers per hour, maybe?
We're using Eastern Europe.
Yep.
Or Western. Whatever.
Yep. What other speeds? You could do, what do you think MPD is? Miles per day? I mean, what are you kind of noticing here? It's going to be a distance, a distance over time.
Oh, I have a question.
You guys just learned your first equation.
Also Mach speed is a thing, so...
Hold on, one question at a time for our people on the thing. Yep.
Could time be endless?
Time is infinite, so far,
That's what I thought.
right?
That's
Yes.
what I thought. That's what I'm saying, like, time is endless.
Yep.
I'm not high, I'm not-
Okay, let's keep going. Any questions about velocity? We're not actually going to talk about acceleration yet. I know we talked about it on our assignment last time, but we're not going to go there yet. Okay. Let's kind of talk about some scenarios here. Okay. I'm going to give you some graphs, okay, and I'd like you to draw them as closely as you can. Alright? So, we're going to start out with a simple one, so position. Let's say it's position. What's on the bottom always? Time. We call this a PT graph, alright? That's kind of why we do this. Zena, you good over there?
Yeah.
The phone? Paying attention? Alright. Okay, let's, I'm going to give you a scenario here. I'm just going to give you this kind of PT graph. How would you describe the motion of this graph? Or the object in this graph? Okay, so it's constant. Let's go ahead and let's assess that really quick. Is it constant?
The position is constant, but the rate.
It would be more correct to say the rate is constant. But what is this thing actually doing?
Moving forward.
Okay, so actually, this thing is moving at constant what? speed or velocity. Okay, what else could we say? I heard some people say positive. Okay, so for this, we're going to say positive is, in this case, and like our lab we did, rightward. Okay. Now if I asked you, now I want to have the velocity graph, I think some of us will probably be able to remember, what would this velocity graph look like? Because it is moving, right? This object is moving. It's moving at a constant speed, which means my velocity or speed is going to be 0 or what? Should look like this. Maybe that's at, I don't know, 5. Who knows? We're not using units yet. Okay, but we say that this is a constant velocity. Okay? Yep, feel free to go to the back side of your guys' notebooks if you have to. This is a constant velocity, unchanging. Okay, really, really important here. You're going to try and tell me this later. This is not stopped or not stationary. This thing is moving at, I don't know, 5 meters per second. Okay?
Which, is that a 5?
Yeah, maybe it's at 5 meters per second or something like that. We're not using units yet. And then I could also ask you to describe this in words. Okay, so if I say, I want you to describe this, you could maybe say, object is traveling right with a constant velocity. That would be complete description of that using words. Okay? Alright, now you guys on here are going to practice with the sheet that the sub handed out, and actually we'll go through a couple more videos on when we go through that. Okay?